Hello, good morning, ladies and gentlemen. Welcome back once again, and welcome to my part 5, number 5 video of this networking series. And today we are going to talk about something really interesting. The last time we did a video, we did talk about a whole lot, LAN, one, or whatever. But today we are going to talk about something which is very important. It's key in the networking thing. Is really key. So as I said, my name is Kenneth Hack. You can follow me on Facebook. You can follow me. Yeah, I think Facebook will do. I'm only on Facebook, but you can follow our team. That's Brainsoft at Ken Hack. The Ken is KENN_hack. At Twitter, you can follow us on Twitter and also on Facebook as well. You can also subscribe to our channel here on YouTube, Brainsoft, and we are glad to embrace you, to welcome you to this big growing family. So now, without wasting my time, let us get into the let us get straight into the real business. I was twisting with the language a little bit, but never mind, it's not my language. So now let us move on. We are still on the networking basics, which is the chapter 1 of this series. The chapter 1, we have, I think I learned it was 13 to 15 chapters. Yeah, and I did explain that in each chapter we have subtopics. So we are still in chapter 1, and we have subtopic called signals and protocols. Now we are going to talk about signals and protocols, but there's one thing you need to take note. For protocols, we are just going to brush through a little bit, because protocol goes in line with the OSI layer model. That's the seven layer model. That's the application, the session, the data link layer. You can name them. You can name them by yourself. So we will do that. We will just do a little intro to protocol. We will introduce ourselves to protocol. Then we will get into protocols itself, where we are going to talk about the TCP/IP protocols and how it has a link with the OSI layer modules. So now, without wasting much of your time, let's talk about signals. What is signals? All computers, all of the computers that you see around that are connected networkally. Yeah, let me take my time so that I can use the words very well. That are connected through network, communicates by exchanging signals. I hope you get what I'm saying. Computers. Now, let me try to explain something here. Now, we have this computer here. I always use these horrible drawings for my examples. Computer 1, we have computer 2. Now, they communicate to each other. They use what we call signals to communicate. That is one thing you need to know. Okay, good. As I said, they use signal. But here is the case. The type of signals which is being used in the communication between these computers actually depends on the medium that sits in the center that helps for communication to take place. What I'm trying to say is, we have a medium that enables communication to take place, and this medium can be maybe a wireless router or wireless access point. It can be a coaxial cable. It can be UTP or STP, or shaded twisted pair, the RJ45 cable. It can also be a fiber optic. It can be a fiber optic. So with these mediums, depends in these mediums, the actual signal depends on it, and the medium will determine the type of signal that is being used. If you are using, example, fiber optic, you are not going to see electrical. No way. You are going to see light. The signals are going to be light signals. If you are using a coaxial cable, you are not going to see radio or infrared. You are going to see what we call the electrical charges. That is going to be transmitted through the transceivers of these gadgets. So that is one thing you need to know. So this is just a short explanation. Now, we have the 3 most common, listen to me very carefully, the 3 most You have other ones there. The three most common types of signal used in network communication are three. We have three. Are simple. We have the one is the electrical, light, and radio. So what we are going to do in the next chapter is we are going to pick them one after the other and explain with examples what we meant by the electrical, the light, and the radio. Now let's move on to electricals. Now electricals. Network that use copper-based cable as a medium communicates by using electrical signals. Voltages generated by the transceivers in each node. It's very simple. It's really simple. There's the case. Let me use another horrible drawing to do this explanation. I have this PC. I think this PC looks a little bit nicer than the first one. And there's a signal being transferred to, oh, what a horrible computer. It's really horrible. Never mind. So we have this communication between computer A and computer C, or node A and node 1 and node 2. Yeah. And in this case, we have a coaxial cable. Please forgive me with my drawing. I'm using the mouse to draw, okay? It's something a lot of people can use to draw. Now, you have this coaxial cable here. This coaxial cable. The coaxial cable is the medium which network is being connected between these two computers. And as a medium, it uses electric. Electric is an electrical gadget. So, at the end of each node, what we call voltage generated by transceivers at the end of each node. So the transceivers at each node generate what we call the voltage, which are the signals, so that data can pass through them. So this is what we meant by electrical signals. Now let us move on. Now I have an example here. There is a coaxial cable for you. You can see a coaxial cable. This one, nowadays we normally see them at the back of the televisions. Yeah, we normally see them at the back of television. So you see, without this, even the television you can't view. That is one. You can't view the television, you can't watch. And please take note, you can get electrocuted through this. You can get electrocuted. It's not often, it's not normal, but you can really get electrocuted. So take note of that. Let's move on to light. Now, when you talk about light, there is one thing that comes to mind in networking. When you talk about light signal, there is one thing that comes to mind. Nothing else than fiber optics. Fiber optic uses light to do its signals and transfer of whatever. So there we go. Fiber optic cable carries signals in a form of pulses of light. And some wireless network uses infrared, there we go, light as a signaling medium. Now let me show you one fiber optic. So we have the fiber optic here. That is one. So let us move on to the next one, radio. Unfortunately, I don't have any radio picture for you, radio waves or whatever. But most wireless networks communicate by using radio signals. That's the wireless, what we normally use as the wireless Wi-Fi, whatever. That is. Now let us move straight from signals to protocols. But there is one thing you need to take note. Signals and protocol have something in common. One is complementing each other. No, they complement each other actually, but one does something for the other, for something to be achieved. Yeah, we will get into that. Now, in each of these cases, the signal form a simple code. Let me just brush through that one. The signal forms a simple code that enables the computer to transmit data over the network. That's one thing I didn't talk about, but I think it's very important if you get to know. So let's move on straight to protocols. As you can see on your screen, we are going to talk about protocols. Now, what is protocols? For me, if you ask me what is protocols, I will just tell you, they are a set of rules. I remember when I was in class, when I was studying networking, my teacher asked me what is protocol. I said, they are a set of rules that governs the communication of two computers, or that govern networking. No, it's true. There are a set of rules. Protocols are a set of rules that you need to follow. in terms of networking needs to follow. If you are doing network, you need to follow those protocols to achieve a successful communication between two nodes, two or more nodes. That is it. They are set of rules. But also, we can also explain it in a different way, a little bit. I mean, I don't want to say complex, but a little bit detailed way for all of us to understand. So, what is protocols? Protocols are software components that reduces complex data structures. Listen to me and listen to me very, very, very well. I said they are software components. It is not a software. Get it straight. So this is the word. The word we are talking about. So component. This is the word. This is the word here. This is the word we are talking about. Component. A software component that reduces complex data structures such as print jobs, email messages, and video streams into simple signals. We will get to know how it does this thing. How can a protocol reduce a huge data into small structures so that it can be transmitted across a network. We will get to know that one. We will get into it very, very, very soon. Now, let us move on. Protocols are essentially languages. There we go. They are essentially languages that operate at various levels of the networking software on each computer or other devices. It's very simple. Now, that's what I said. We will go into protocols into detail when we are doing the OSI layer model. We will talk about that one very soon. I think after this video, the next video will be the OSI layer model, so that you will get to understand what we are talking about and how to explain how data is being transferred from one end to the other and how it's being received. We will talk about all these things, the security and the vulnerabilities. We will talk about them. Now let us move on. These are some of the protocols we can find. The easy ones we can find. We can remember the TCP IP protocol. We have the UDP. We have the SMTP. We have the HTTP. We have the HTTPS, and so many more. But that is what we are going to talk about. Still, we are on protocols. As I said, protocols as a language or set of rules also help in everything when it comes to the transmitting of data or the sending of something, the communication between two nodes. Networking protocols can provide many different functions to the data structures on which they operate. The protocols protect the data as the computers transmit it over the network. That is one thing you need to know. It protects the data. It does a lot of things to data. And one is the addressing we are talking about, is one. As I said, it protects the data as the computers transmit it over the network. And see it to that it arrives at the destination, or it arrives at its destination. Some of the most important protocol functions. So what we are going to talk about right now are functions of protocol. I didn't write it there. I should have. I'm sorry. What we are going to talk about right now is functions. So what we are going to see here are the functions of protocol. So these are some of them. Let's start with what we call the addressing. One function of a protocol is that it addresses packets or data. That's addressing. A system for assigning a unique designation to each computer on a network and using those designations to transmit data to specific computers. We have different types of protocols, and the addressing is done by a specific protocol. I'm not going to mention the protocol name here. When we get into protocols and OSI layer model, we will talk about the addressing, but let it be in your mind that the addressing is done at a specific layer, is done by a specific protocol. That is it. 2, we have the acknowledgement. What's an acknowledgement? The acknowledgement is the transmission of a return message by the receiving system to verify the receipt of data. So it's simple. Let me try to explain this to you. When you talk about acknowledgement, data is being sent from PC1 to PC2. Now, the first protocol has done its part by giving address to 1 and 2. So there is this address. Now, I want to send a letter from 1 to 2. 1 knows the address of 2, and let me state this. That is when the IP address comes in. I don't want to make it more complex, but let me try to put that one in. That is when the IP address comes in. So I have 192 dot whatever. I'm just using this as an IP address. I know it's not, but forget it. And I have maybe 192 dot maybe 2 dot. Let me just use this to represent an IP address. It's not, please don't write it anywhere. I'm just using it. So now this 192.1.1.1 is the address for this network here, this node here, and it is sending a message or data to 192.2.11. Now it knows the destination, that's the addressing. So as soon as PC2 gets hold of the data, it sends a message to PC1 telling PC1, thank you very much, boss, I have received your gifts. That's what we call acknowledgement. It has acknowledged that the gift has arrived safely and sound, no problem, no hitches. So that's what we call acknowledgement, and this action is actually done by a specific protocol. You need to understand the way networking works. I hope you get me. And when you understand it this way, I think you are good to go. You are really good to go. So this one is done by a specific protocol. You need to know the protocol name, its functions, then you carry on with it. Now let us move on. The next one is segmentation. What do we mean by segmentation? Segmentation? What is this? Someone will ask, hey, what is this? Segmentation. Okay, what are we going to segment? Let us see in this one. I want to clean these horrible drawings, then I'll move on. Let me clean it. Let me try to clean it. Okay. No pen. Okay. Now, when you talk about segmentation, what we mean by the division of a large block of data into segments sufficiently small for transmission over the network. Now, let me try to explain. This one is also taken care of by a specific protocol. I'm not mentioning names today. I'm not going to mention any name of a protocol. What we are going to do is, in our next video, we will talk about protocols and we talk about the OSI layer model, and we are going to tell you at which level this is being done, at which level this one is also being done, and we will tell you the protocol that is involved in the action. So that's what we are going to do. Let us move on. When you talk about segmentation, it's very simple. I have a data there's a full data. Maybe it is a let me say just a data, don't worry, just a data. It's just a data. I have this data here. I want to send the data across the network to a fellow friend. The data is too large. It can't, it can't go through the network just like, it's like sending a 1 gig or 1000 megabyte data to a friend somewhere. It takes time. It takes time. Ask yourself, why is it that it doesn't go straight? And just enter. There will be traffic. There will be traffic on the line. Why is that it doesn't just go just like that? It needs to segment this data. It needs to break it down into pieces, smaller segments, so that it can be transferred across the network to the fellow friend. So this is what happens. This is what happens. This data is being divided into, I don't know how many parts, but maybe 5 or something parts, and it will be sending one at a time. One at a time. No, one at a time. As soon as my friend receives the data, another protocol is in charge of building the data once again for it to be a full block data again. So it takes it in pieces and it builds it up. That is it. It takes it in pieces and it builds it up to form a full data, whether a video, whether a music, anything, so that my fellow friend can use it. So that is what we term as the segmentation. Let us move on to the next one. Flow control. This one I don't need to talk much. Protocol actually controls the flow of network, the flow of data on network. It can slow it down, it can increase it depending the situation it finds itself, the network finds itself, depending. So the flow of data or flow control, the flow of data, let me use the flow of data, the speed and everything is being controlled by protocols. That's one thing you need to know. Now let us go on. Error detection. Protocols, sometimes I quite remember I was sending a message to a friend and I got an error. At that time I was not into IT, though I love computers, but I have not decided at that time to do networking. So I said, why error? It is the protocol that has detected the error for me. And the inclusion of special codes in a data transmission that the receiving system uses to verify that the data was not damaged in transit. It's simple. Now you understand? You can download a movie, or let me use as a software from the website. After downloading it, when you try to open it, they will tell you it is damaged. It is the protocol that detects the damage of that data. It's the work of the protocol. So that means you need to re-download it again. That should tell you that there was a problem in transmission. There was a problem in transmission. Something happened, which I don't know. We live to see. Let us move on. The next one is error correction. The transmission of data that has been corrupted or lost on the way to its destination. Error correction. So it's a self-explanatory something. The next one is encryption. Encryption. The encoding of data with a cryptographic key to protect it during transmission over the network. Now, it's very, very important. If this thing is not there, we are going to get a lot of problems. People are going to look through, these bad people are going to look through messages that people send across the network, what people receive, documents, videos, pictures, that's what we call hacking. People are going to hack into people's private messages and stuff like that. Let me try to explain what we mean by encryption. Now, I can here, I want to send a picture to my wife. Let me use my wife so that people will know the importance of this protocol. I want to send a picture to my wife. Maybe it's a love picture, not a naked picture, a love picture. As soon as I send it, there is a protocol in charge of encrypting the data so that this guy here and this guy here who are trying to fish out something on the network will not get access to what I'm sending. Even if they're able to see what I'm sending, if they are able to grab what I'm sending, they can't see it because they can't encrypt. When I talk about encrypt, open. They can't have the key to open the data to see what is inside. What's inside it. I mean the main content. They will see it maybe just a file, whether a picture or a video. They will see that it's a video file, but they can't view it. That is it. So it is very, very, very important. It's really, really, really important. Now, let us move on to the next one. The next one is compression. The removal of redundant information from data blocks to minimize the amount of data transmitted over the network. Now, when you are sending a data, you can have some surplus data that are not needed. The protocol is in charge to take all, things which are not good, which are not useful, that is making the data large. It takes it away and it reduces the size and minimizes it. It minimizes it, compresses it. Compression. It doesn't take the data away, but it compresses it. Maybe you can have a data being sent 500 megabytes to a friend, and this, what do you call it? This protocol will compress it to maybe 490 megabytes. You've saved 10 megabytes. So that is the importance of this one too. Now, we are done with the functions of protocols. Now, there's one thing we also need to know. Most of the networking protocols that we use today, which I've been talking about, the HTTP, whatever, that we use today, are open standards, so that different manufacturers can produce implementations that are fully compatible. That's one thing. All these protocols are built by institutions, and these protocols was built to form a certain standard, to give us a certain standard, so that manufacturers, whether they manufacture a computer, they manufacture boards, network adapter, network cards, or whatever, they can follow this procedure or these standards for us to get a good networking or network. Let me use this to explain what I meant by what I was saying. In the olden days, I was not there, but let me tell you something. In the olden days, if you want to connect maybe a Samsung switch to maybe an HP router, is impossible. It won't work. That is it. It won't work. You need to connect Samsung to Samsung, HP to HP. The manufacturers were building their own thing, using their own protocols, which makes things very, very, very difficult. Very, very, very difficult. So for easy communication and easy access, they came up with these standards. Because these standard protocols, and that's what we know right now, the HTTP, the HTTPS, and the rest. Those are standard protocols that each and every manufacturer across the world, across the globe, will use to build his or her gadgets. So these are the standards. So we are going to look at the institutions that are responsible for designing the networking protocol standards. That's what we are going to look. We are not going to read about them. We will just be mentioning their names So if you see anything attached to the name, you see that this is a standard product or it's a standard something. Now let us move on. The first one we are going to talk about is the Institute of Electrical and Electronic Engineers, that is the IEEE, the US-based society responsible for the publication of the IEEE 82.82.3. It's not 82, 82.3. You know, IEEE is responsible for, is known for the protocol of Ethernet. They are commonly known as Ethernet. You know, this Ethernet is nothing but network or computers that are connected, that are networked through cables. Get it straight. Computers that are networked through cable. You can have the UTP and the STP. That's the RJ45 cables. Yeah, that's what we meant by the Ethernet. So if you talk about Ethernet, we are not talking about wireless. Is not Ethernet. Cables, cabling internet. That's what we term as Ethernet. Now we have the ISO, International Organization for Standardization. We have the Internet Engineering Task Force. We are not going to talk about them much. We'll talk about the American National Standard Institute, ANSI. We have the Telecommunication Industry Association, Electronics Industries Alliance, the TIAEIA. We will talk about them too. We have the Telecommunication Standardization Sector of the International Telecommunication Union. So those are the things we've talked about today, and actually we've spent a lot of time on this. So I would like to end it here and call it a day. I say thanks for watching. Please don't forget to subscribe. If you have any problem, just leave a comment. Just write to us at Brainsoft. You know, you can write to us at brainsoftgh@gmail.com, and I'll be happy to receive your mails and read them out, and also find a way to solve problems that you have. We are starting something. You know, you will definitely get problems. You will definitely get hitches along the line. Sometimes you fumble with the language you want to use because it's not my language. You fumble with it, but all the same, you know, we don't get carried away. We move on. Then we hit it hard. We are doing our best. So thanks for watching. It's Ken Hack here, and see you on the same channel. Bye for now, and please, when you say a prayer, say one for me too. I love you. Bye.